how many there are and stuff like that. So Parth said prime numbers are infinite. There's infinitely many. But how do you know that? You just assume it, right? Because there's infinitely many. But the primes get farther and farther apart. So how do we know how many there are? Like, how do we know they're infinite? How do you know they're not a certain collection? So that's our question. Are the prime numbers infinite? Yes, sir?
That's because if you divide infinity, you still get infinite.
Infinity is not a number, so you can't divide it. You can't divide something by an idea, and infinity is only an idea. There's actually no physical examples of infinite that we know of. I know I mentioned that like in the first week of school. Like we think maybe there's we live in an infinite universe. It's quite possible, but we don't know. What? What about time?
Technically, it doesn't have a...
It doesn't. Technically, time is a human invention.
Well, yes, but
Time would have a start.
But everything moves.
Because before there was nothing, was there time?
Well,
Time measures. But listen, time measures how long it takes to travel from one thing to another. If those things didn't exist, you wouldn't have time.
Well, yes, but if nothing existed, how long did nothing exist?
Time is just an idea.
Time's just an idea. It might be entirely a human construct because we're limited by these physical things. So that's what time is. It relates how long travel is. You know how it relates to how long of our lifespan it takes to move from one place to another. So check this out. That's a good idea. Yeah, I like the time thing. Time is interesting. Okay, so do you guys remember this? First of all, we're going to say let x be a natural number, and we're going to make it greater than 1 because 1's no fun. Brandon should definitely stop looking at Dylan. He should definitely turn all the way around and face the front. You're smarter that way. You'll see. Students that face sideways aren't learning very much, right, Tristan? I don't know why that is, but it's very, very true. Students that are sitting sideways in their chair, they're just not engaged. They're just comfortable. All right. You guys remember what this exclamation mark means?
Yes.
What does it mean?
It's like multiplying, like counting down.
Yeah, multiplying, like counting down. It's called factorial, right? It's called factorial. So like 5 factorial would be 5 times 4 times 3 times 2. Really times 1, but we don't, times 1 doesn't change it, right? Brandon, you good with all this?
Yes.
Yeah, you sure?
Yep.
Okay. Is 5 factorial prime or composite?
That is composite.
Why?
Because those are the factors.
Because it has more than 2 factors, obviously, right? So all the factorial numbers, except for 2 factorial, would be composite. 2 factorial would be 2 times 1, and that's just 2, right? But 3 factorial would be 3 times 2 times 1, 6, right? So that would be composite. So all the factorials that we're going to be talking about besides 2, they're all composite, right?
Yep.
Okay. Now let's talk about another number. Let's talk about a. Let's say a is natural also. Okay? And let's say a is less than or equal to x. Whoa. Bomb. It's going to be a boom. All right. Allison? So like in this example here, x would be 5, right? So that means that a could be 5 or 4 or 3 or 2 or, right? Do you guys follow me?
Yes.
Yeah? Okay. So could a be 3?
Yes.
Yeah? Okay. This number right here, this is one number altogether. Do you see? Is it prime or composite? And how do you know? Whoa, it got awful quiet. Dang. Kevin, what do you think? You think it's prime? Why do you think it's prime? Because it ends in 3? No? Check this out. What do you think, Jesus?
I'm at, right? So since 5 times 4 times 3 times 2, so like there's a 3 in there,
So this is some number times 3, right? And then you're going to add 3 to it. So then what does that mean?
That you're just like, it could be divided by 3.
That means 3 is a factor, right? So it's composite. Because it's not 3 itself, it's 123. Do you see? It's like skip counting. Like 3 goes into 27, right?
Goes into 12.
And so, yeah, it goes into lots of stuff, but 3 goes into 27, right? So if I skip and I add another 3, that's 30, and 3 goes into 30. And if I add another 3, that's 33, and it goes into that, and then 36, and 39, and 42, and 45, and 48, and 51, and right? So if you start with a number that has a factor of 3, and you add 3, 3 is still a factor of that new number. Does that make sense? I mean, I don't know. Pierre, does that make sense to you? You sure? Yeah? So then, what if I had this then? What if x was 7? Okay? So what if x was 7? So I had 7 factorial plus 7. Prime or composite? Composite, because 7 will go into that whole number, right? Okay. 7 will go into that whole number. Now, check this out. Let's go back to 5 factorial. 5 factorial is 120, okay? Let's do 5 factorial plus 5, 5 factorial plus 4, 5 factorial plus 3, 5 factorial plus 2. This would be 125. This would be 124. Are we good? 123, 122. And here's my question. Is it possible for any of those numbers to be prime? Dang. Anaid, what do you think?
No, because they all go into, like, all the numbers are inside.
So like 5 goes into this number. 4 goes into that number. 3 goes into that number. 2 goes into that number. And it will always be that way. So if I did it for 17 factorial, right? How many numbers for sure after 17 factorial would be composite? 17 more numbers. Yeah. One might cause us some trouble, right? So check this out. Oh, hi Nayeli. How was it? Oh, you look sad. Are you a sad panda? Oh, okay. Thank you. So check this out. Here's what we're saying. 120, of course, is composite because it's 5 factorial, right? And 5 factorial plus 1 would be 121, right? And then 5 factorial plus 2 is 122. And then we have 123, 124, 125. And all of those, right? This one perhaps could end up being prime. Could be. It's not here. It's 11, right? 11 squared. But all of these, is it possible for any of those to be prime? And Nayeli said no, they'd all be composite. Because 2 is a factor of this, 3 is a factor of that, 4 is a factor of that, 5 is a factor of that. Not because of the last number, but because of how we got them. Do you see what I'm talking about? So that's a gap of 4 numbers that are for sure composite. 4 numbers in a row for sure are composite, right? Okay, now watch. What if I had 21 factorial? I don't want to write 21 factorial over and over again. So I'm going to say this is just k. So k plus 2, k plus 3, k plus 4. These are all individual numbers, right? K plus 5, k plus 20, k plus 21. Any of those prime? Is it possible? Why, Allison, is it impossible for any of those to be prime? Do they all have to be composite?
No. Only.
They all have to be composite. Because, like, let's take a look at this one right here, right? That would be 21 factorial plus 5. So 5 is a part of this, right? And then you add 5 more. So this number right here is a multiple of 5. You add 5 more, it's still a multiple of 5. So 5 will go into that number. And like this number right here, this is 21 factorial. 3 is a factor of that, because 3 is part of it, right? Because that's 21 times 20 times 19, 18, 17, 16, 5, 4, 3, 2, 1. So 3 is a factor of this. Add 3 more, it's still a factor. So we have a gap. The 1 might be prime, but we have a 20 number gap of composites. Anybody see where this is going yet? No? Abraham, you see? Abraham, how big could the number x be? Like if we go back to our original, how big could this be? What, Brandon? Oh, wait. Abraham, I meant. I'm sorry. Abraham. No, I said Brandon. Abraham, how big could that be?
Could it be?
Yeah, how big could x be?
Big as you want?
As big as you want it. X is a natural number. There's infinitely large natural numbers, right? So here's what I'm saying. Like, let's say x is, let's see. That's a pretty big number. Let's see, that's, whoa. What, is that a trillion? Wait, that would be a million. This is a billion. This is 1,000,000,003 factorial. That's so big of a number your calculator wouldn't be able to figure out what it is. Well, not even your home computer. Your home computer would probably just melt. It'd go, Really. Your computer at home probably couldn't figure that out if you have a home computer. But here's what we're saying. Oh my gosh.
What are you doing?
Are you going to write it all out?
Would that be prime?
No.
That would have to be composite, wouldn't it? Because this number here is a factor of that number, and it's like skip counting, so how big of a gap? Like, all of these numbers, like, I'm not going to write it all out, right? But, like, 1,000,000,002 plus 1,000,000,001 plus 1,000,000,000 plus 999,000,009, right? All the way down to 2. All of those are composite. That is a 1,000,000,000. Wait. That's a gap that big between primes, guaranteed. Do you see what I'm saying, Parth? In fact, I could do this. Well, that's supposed to be a 3, right? Factorial to the factorial to the
Are you just going to put in powers, mister?
factorial. That's a gigantic number, right? However big that number is, that's a big, giant number. There's a gap that long between, there's a gap that long for sure that every single number in here is composite.
Wow.
Parth, you see what I'm saying? Yeah? Mikey, you see what I'm saying? Every single one of these numbers, like if you started at this number right here, whatever it is, and you added like 1 to it, well, you added 2 to this number, composite. Add 3, composite. Add 4, composite. Add 5, composite. Add 6, composite. Add 7, composite. In fact, check this out. If you added one number to this number every second, you wouldn't be done for 32 years. Seriously.
Whoa.
It would take you 32 years to add one number at a time to this, and every single one of those numbers guaranteed to be composite.
A 32-year gap.
One number every single second for 32 years. Every single one of those numbers, composite. So if you had a list of numbers and you were checking them to see if they were prime or composite, every single one of those numbers would be composite. Parth, you sure there's infinitely many primes? I'm sorry I'm picking on you. You were just really confident that there were infinite primes because numbers go forever. What's that? There's infinite composites, and it looks like there's infinitely large gaps of composite numbers with no possibility of a prime between, because every single one of the numbers in here is composite. Like you start at this number and you add 1, 2, 3 until you get that many numbers added to it. Every single one, composite. Abraham, is that crazy? So Abraham, what do you think? Do you think that primes are infinite? Not anymore? Okay, they are. Watch, I'll show you why. Oh, good Lord, I love this. If Hitler was a math teacher, he would not have killed 6 million Jews because he would have been paid to, quote unquote, teach, aka torture, students in math. Okay, Nayeli, check this out. There are infinitely many primes, and the way I can prove it, I can prove it to you right now. I can prove that there are infinitely many primes by assuming that there aren't. And then watch. So let's say the primes are finite. You could write this down if you wanted. This is a cool proof. This might be your first mathematical proof. So there are finite primes. Since there are finite primes, does that mean you could write them all out? If it's finite, you can write them out. No, but we're going to assume that it is. So they're either finite or they're not finite, right? So let's assume that they are finite and then see what happens, and we'll see that's impossible, which means they have to be infinite. Okay? So we could list them all out. Okay? What if we listed them all and multiplied them? That new number would be a really big number, correct? But it would be composite, right? Because every prime number smaller than it would be a factor, because that's how you got that number. You multiplied all the primes together to get this new big ugly number, yeah? So this new ugly number would definitely be composite, because every single prime would be a factor of it, right? Okay, add 1. It's prime. Because no prime number smaller than it would be a factor of it. Because no smaller number would go into that number. Sure, I can't do them all, but let's say this was the collection. Like we could make the collection as big as we wanted, but it wouldn't matter. So let's say this is all of the prime numbers. There are no more. Okay? Let's see, we'll multiply them together. 6 times 5 is 30. This is 210, right? Yeah? 210 is, of course, composite because 2 goes into it, 3 goes into it, 5 and 7 all go into it, right?
Yep.
2 doesn't go into it, 3 doesn't go into it, 5 doesn't go into it, and neither does 7, because it's off by 1. That means this would be prime. Dang.
Holy moly.
That make your head hurt, Jesus? Yeah? Okay. All right. Guess what we're going to go do right now?
Look at the sun.
We're going to go look at the eclipse. Ready?
What?